Thank you very much, Sebastian. Yeah, welcome also from my side. I will, since I'm aware of the timing, I will try to keep it brief, the presentation. And thanks also to the previous speakers. I found it also quite interesting. It seems to be quite sunny in Denmark, so I'm connecting from Karlsruhe in Germany, where it's a bit cloudy today. My name is Robin Barkhausen, and I will present a bit, give you a deep dive into one specific action type, which is on early replacement of electric motors and how to calculate their energy saving potentials. And basically, this means that we combine three different topics. So we have electric motors, which are responsible for actually a very large share of the total EU electricity consumption. Estimations talk about above 50%. We also have a lot of motors in the EU. The EU itself talks about 8 billion motors, but I guess this figure is a bit high. So in the EU-MORE project, we did our own assessment, and now just talking about the industry and tertiary sector, that we assumed that it would be 120 million motors. So still quite a lot. And if we combine this together, there's a lot of high impact and of course, high energy consumption, high environmental impacts related to electric motors. Which brings me then to the point how we want to tackle it. Well, it's policies, motor policies. So inside the project, we also did an analysis of the different policies which exist in different European countries. These policies have the goal to reduce the environmental impacts or the energy consumption. The focus is on use phase and energy particularly, but also CO2. So the Eco-Design Directive is there, which sets the overall minimum energy performance standard, so decides what is allowed actually to come to the market. And then we have more specific policies on the national level, financial ones and also non-financial ones. And then the third basically component of the EU-MORE project is then the early replacement. Why we look at this? Well, because actually there are a lot of old motors still on the market, and those motors are quite inefficient. They have a high energy consumption, and the idea is to replace those old motors with more efficient ones. And then we combine these three topics, brings us to the topic today of my presentation, which is on how to estimate the impacts of motor replacement policies. This was carried out under the EU-MORE project. So EU-MORE stands for the European Motor Renovation Initiative, and the goal is to speed up the replacement of old inefficient electric motors in the EU. It's an European project funded under the LIFE program. And one of the tasks, actually you see it in purple at the bottom, is that we also develop these tools for protection, where I will give you a bit of an insight today. We have 6 partners in the project. So it's the University of Coimbra, International Copper Association, IECP also, Austrian Energy Agency, CRES from Greece, and Fraunhofer ISI, where I am from. The agenda, I will keep it very brief today, every point of this, but I want to give you a brief insight on why and how we developed our model, give you a short peek into the tool, and then talk about one application study, and the reflection, I guess, will directly transfer into a discussion since the time is short. Starting with the why and how. Why we created the tool? Well, it is designed to analyze policy impacts of policies on electric motor replacement and created to help stakeholders and policymakers to understand or to make better policy decisions in the end. The scope is in large parts determined by the other parts of the EU-MORE projects, and particularly the model was developed in task 4.2. But all the other tasks where we did, for example, an electric motor market analysis, looked at end-of-life practices, we did motor system efficiency trends, and also the analysis of policies. They all basically feed into the model to provide the background data and some of the assumptions. With that, then we developed our own model. The scope of this model is the EU27 market, but also you can zoom in into individual member states. It's for industrial electric motors, which we divided by technology, power range, and efficiency class. The logic behind this is we did a multi-dimensional stock model. So it means we have different layers. We assess the energy consumption, the materials, where you can select basically one material flow which you want to assess, for example, copper or aluminium. And also we have the environmental impacts in terms of the greenhouse gases. And everything is implemented in Microsoft Excel. We did this because we wanted to have it easily accessible. So the tool, as you will see later, is available on the project website, can be downloaded and used there. The policies we looked at were chosen on the review, which was done in the project before. You see some of the results graph on the right. I will not go into all the details. Basically, what we came out with, the result, we selected it was found that those policies are mostly financial ones in the EU, encouraging the replacement of old motors with more efficient ones. You see here some example of the subsidy scheme, for example, in Portugal, Switzerland, also tax incentives with volunteer agreements, and lastly, information campaigns and capacity building. Then translating this into the model, we basically decided that it will be mainly financial policies which we look in, because these are the most common one in the EU, and also the ones which are easiest to model in the end. And we decided for subsidy scheme and tax rebates, which work a bit different in how they deliver the financial support, but in the end, the modeling is quite identical. And we also have non-financial incentives, but there we merely or only work with cost efficiency ratios from existing programs as an orientation. At this point, 2 slides on a bit of the logic and the combination to the Energy Efficiency Directive. So basically what we do, the motor model calculates savings compared to a base case without a policy. So for example, if we replace motors 2 years earlier, then these savings are counted for those 2 years when the motors are replaced before their normal end of technical lifetime. So it means we would have a 2-year lifetime savings. But if these replacements is actually better than the market average at this point, then the savings are realized over the entire new motor lifetime. And the same also applies then to energy consumption, CO2 savings, and energy costs. Just a few words on the Energy Efficiency Directive. On the right, you see here at the bottom the sentence basically saying that savings are claimed only for the period until the end of the average expected lifetime of the product or vehicle to be replaced, which means that our logic by having this base case with policy, this case with policy, and then this base case without a policy, and compare the 2 scenarios against each other, we actually align with this logic. Which now leads me to give you a short peek into the model. I actually was already presenting a longer presentation on this 2 weeks ago in the Motors Academy, so this is still available online. So if you are interested into more details, you can check that out. And also we have a lot of information materials on the tool on the EU-MORE website. So today, just a short peek. You can download the model on the EU-MORE website directly as an Excel version. There's also an online version which you can use there, and basically just shows you here how you can do it. Just like 3 slides or 3 images from the tool. So basically you enter it just so you have seen it. You have the landing page where you have a bit of information materials on the tool, who has done it, how you can provide feedback, and so on. Then you have here different tabs to navigate, and the dashboard is basically where you insert your policy parameters, and also at the bottom get displayed already the results. And finally, we have also the graphical results, where some of the results are displayed in graphical format. And with that, I'm coming to, I think, my last 3 slides, more or less. So a bit on results, just to give you an introduction of what actually can be done. So I designed here a theoretical subsidy program of 2 million euros. So I applied it to the EU average country, basically, which represents somehow Belgium or Netherlands in terms of the electricity production. And this program would fund 50% of the new motor cost, which is aligned actually to existing schemes like the one in Portugal, the Portuguese Energy Efficiency Promotion Plan. We apply it to motors from 37 to 75 kilowatt, and it's active for 5 years from 2025 until 2030. And we replace IE1 and IE2 motors, which are very inefficient motors, with the higher efficient IE4 motors, and do this 2 years before the normal end of lifetime. This example is theoretical, but I still use it to give you a bit of basically insights into what can be calculated. And here is what can be calculated, so the key outcomes. We see that on the stock level, so we have the results basically divided into those on motor and stock level for industry and policymakers, and also for economic, environmental, and material impacts. The stock levels we see with this 2 million program, we are able to replace 1,206 motors in the lifetime of the program, and then the savings, of course, are generated over the entire lifetime of those motors. And we achieve total energy savings of 34 6.21 gigawatt hours until 2050, which is more or less the consumption of almost 10,000 average European households in a year. And we have electricity cost savings which are related to this, which almost 6 million euros, and we trigger 1.6 million of additional investment by the industry for buying those higher efficient motors. Some further results, we have environmental impacts, which accumulate to about 12.14 thousand tons CO2 equivalents, which is more or less 2,600 combustion cars running for 1 year, just to give you the dimensions. And the material impacts, the thing is that these IE4 motors, they will have a higher copper quantity in them, so we will need a bit more on the entire market level, a copper demand of 26 tons. But here I actually have to notice that we do not, or the model does not take into consideration the recycling, so this is basically just not taking into account if we recycle those old motors. Of course, we could partly recover this copper from the recycled motors. And with that, I'm almost done. And I think the reflection, we can move into the discussion if there's some questions, since we're already above time. And I will already end my presentation here. I hope it was not too quick. And yeah, looking forward. If there are any questions or if we directly ended, I could also understand that.
Yeah, so sorry, Robin. I hope you didn't have to rush too much. I put in the chat the link to the presentation you made early January. So if you are interested in knowing more in EU-MORE and especially the EU-MORE model developed by Robin, I really encourage you to look at this presentation where you will have more time to get familiar with it. You will see how to use it more in detail, and it's an open tool, right? You can get it from the either you work it online or you can download to your own computer to play with it. So that's I think a very nice and useful tool. The approach, what I take from the approach is that it's quite interesting to have this stock modeling or market modeling to analyze, to assess the potential of policies. So before we discuss, let's say, the potentials related to type of actions in general, but here you go a step further, looking at the potential of a particular action type in the context of different type of policy. You provided examples at the end of your presentation. And also the fact that you don't focus only on energy savings. You mentioned the materials, and obviously for motors, copper is probably the main one, but I don't know if you covered other materials in the tool. I think, yes? No?
We have more materials, but since it's mainly induction motors, which we have in the model at the moment, like these critical raw materials are not included in the data we have at the moment. But potentially you could also model them in the tool.
And this is made in the spirit of the development of the eco-design regulation, or that's something you did because you saw the relevance of these issues?
We saw it more, and this is also what I looked into in my PhD. We saw this like development that basically it moves a bit from energy, or from only looking at energy efficiency to looking at other environmental impacts and also material impacts. And we have all these problems with resources overall. So this was basically the motivation there to ask for included, even though it wasn't like a prerequisite for the program or for the project. But we found it important to also consider this aspect.
Yes, and I think it aligns very well with the next step of the eco-design regulation that goes more and more into the circular economy approach and so on. So yeah, very interesting tool and a resource for everyone. We are quite late, and I thank you very much, all of you, to stay. I'm sorry, Robin, again that you had to rush.
No problem.
You can contact the speakers afterwards. We will contact you again to share the presentation file. So you will get the link where you can get the presentation file afterwards, as well as the recordings. We will also send you by email a short feedback survey, and please answer it. That's very important for us to know what we can improve for the next workshop we do. And so to conclude, I would like to thank very much all the speakers. Christophe had to leave, but yes, Christophe, Brian, Solène, and Robin. I think it provided a very nice overview on the topic of energy savings potentials. As you know, it was jointly organized, this workshop, by NFS Plus. So for NFS Plus, that was the first workshop of the learning cycle, let's say, where we share experience between countries. So there will be more next year, so stay in touch. And for ENSMOV Plus, there will also be other workshops next year. That's the last one for this year, obviously. But we will continue next year, especially I can already tell you that on the Tuesday, 18th of February, there will be one on monitoring and verification in industry, where Solène will be involved as well. And there should also be a series on energy poverty. So stay in touch for ENSMOV Plus. You can subscribe to the newsletter. You can follow us on LinkedIn. And the same, if you go on the website of NFS Plus, you can also find ways to stay tuned. And as I said, for NFS Plus, we'll have a new platform early next year as a present to start well the new year. So I thank you very